Callum Augustine here of Knauf Insulation, Project Coordination Manager, and I've been with the business for nigh on 10 years now.
I'm Hirst, Technical Services Manager for Knauf Insulation UK and Ireland. I run and manage a team that support our customers with specification, and we also do technical calculations for things like U values, condensation risk analysis, and 3D calcs.
I am Barry Murphy from Triangle Architects. We're based in Manchester, and we predominantly do residential developments, extra care, anything with a bed really.
Hello, I'm Matthew Prowse from Knauf Insulation. I've been here 20 odd years. I'm Director for Housing, Specification and Offsite.
I think part of the struggle is, correct me if I'm wrong, a lot of architects use repeat specification. So if you did a project 5 years ago, you might dig into that archive and think, right, what calculations did I do for that project? Is there parts of that design that I can take and recycle for the current project? And I think it's a great way to do it. It's obviously efficient for you guys, but what you might not realize is that product spec may have changed. So I think it's really important to use accurate and sort of most up-to-date sort of product literature really to take the characteristics from that you need for your design, especially in terms of performance characteristics. I think that would obviously be something that's key. We do that through publishing it on our website. We would always sort of urge people to use the data from the most up-to-date data sheet, rather than you saving one 10 years ago and then going into it.
Yeah, the website's certainly a good way of approaching things because it have the most up-to-date documents, be that VBAs, be it product literature, all the kind of fun stuff that we relate to. But certainly, I suppose we can attest in our time, there's certainly been changes in some of the VBA certs, for example, whereas some things that were once permissible are no longer permissible almost. So it is certainly good to, well, we do drive the traffic where we can to the website because it does have the condensed library, if you will, of all the most up-to-date kind of product range and all those kind of things.
Especially things like lambda values have changed in recent years as we try and be innovative and put new products to market. We'll create new products with low lambdas, but we'll also try and improve and develop on our existing range. I know for things like flat roof slab, we've increased the compressive strength to make it suitable for a sort of broader range of applications. So things do change, and I think that's, keeping up to date with it is key.
I think the industry's constantly changing. There's regulations changing all the time. The BBA certificates are changing all the time. There's been a lot of change in the last 5 years in terms of what we need to look at. And we've been going towards less of a product approach, but more of a system approach, looking at the whole system. So we can't just reuse what we've always done. We can't just roll out the same set of drawings for this new projects. We need to do the checks every time, talk to the manufacturer every time.
I think as well, you've got a situation where as an architect, you've got to be across everything. So you've got to know a bit about door handles and a bit about paint and a bit about cladding panels and every single little part of every building that you sit in. You've got a very broad knowledge of that, whereas from our point of view, our knowledge is quite narrow, but it's pretty deep. So if you need to know anything about insulation at all, then there's our website and there's the online tools, but there's also the people in my team who can sit down and talk to you and go through it. And I think that those things kind of complement each other, and they're there to help people design it, because why would you be an absolute expert to the depth that say Brad is in just insulation? You need to have an overview of the entire project, right?
We do. It's and we're a middleman essentially. We're a middleman between manufacturers and all the different consultants and people who are building it on site, and we're trying to pull together all of this different information between different products, different consultants, and piece it together into something that hopefully simplifies construction, but contractors don't necessarily think that.
And all the bits and pieces don't you don't want them to be clashing with each other.
No, exactly.
Everything has to work in harmony to make the whole building work.
It does, and it's a two-way street talking with manufacturers. So it may be that we come up with a problem on site or a problem with a detail that has been encountered before, just not by us.
Yeah.
And you may have worked it through with a different architect and can give us that solution. But it may be that we've come up with a problem that hasn't been encountered, and you've got to get your thinking caps on and figure it out.
Yeah,
I think that's where speaking to us comes in. You know, you'll look online and you might not find a solution that fits your bespoke need, but if you come and open a conversation with us, we'll quite happily look at drawings, review the spec, see what we can do. You know, we can model things and do thermal calculations to see if it does work, and sort of bounce ideas off each other to come up with a sort of pragmatic solution, really.
Yeah. Is your preference to do that work and that research online, or is it talking to somebody over the phone, or is it email, or sitting down with somebody in your office? I mean, I guess it depends on the circumstance.
It does, and the starting point is usually a website. It's usually research online and trying to figure out if there is a typical detail that we can use, or if not, is there a typical detail that we can adjust? And we're doing that with multiple different products at the same time. So it may be that a product works in one way, but can we piece it together with another product that works in a different way? Yeah. And it's all of those different criteria you're piecing together with some engineers' drawings, with some mechanical engineers' drawings, with a steel frame and whatever else is needed in there.
Yeah, it's a complex process. I mean, we get a lot of people talking to the guys in my team, certainly, wanting them to come and sit down and, you know, get all the drawings out, get everybody's red pens out and work through a thing, because it's got so complicated for those reasons. Yeah. Somebody's picked up something from a website here, something from a website here, and they don't seem to all gel together.
No, they don't. And there is a lot more complications going on. You know, there's recently and over the last decade, there's been quite a drive for floor to ceiling height windows, essentially. Right, yeah. And if you think about a gap between the head of a window and the sill of a window above, you might have a lot of things going on in there. Yeah. So you've got the window junction with the wall, you've got some sort of structure, you've got a cavity tray, cavity closer, fire barrier, floor junction with wall junction. Masonry support. Yeah. You might have an angle in there holding up the window before the brickwork follows up. So you're constantly looking at sequencing of work, what can go on when, and it does need looking at with experts.
I mean, have you ever been in the room where you've sat down with the insulation person and the cavity tray person and the masonry support person? And because I don't think it's ever happened with me where somebody gets all of those people together in one place so we can all contribute at the same time.
No, it seems to be go talk to one manufacturer, get the information. Go talk to another manufacturer, get the information, and piece it together. And you may have to go back and talk 3 or 4 times, and you may have to use the product in a different way, or turn a bracket upside down, or create a new junction between different products. But you want to get that comfort that it'll still work when you change it.
Because the truth is, a lot of these buildings are not, it's not like you're a national house builder who builds a Tamar house type 1,000 times across the country, and you've got the chance to iteratively improve that design and make it more buildable and whatever. You know, if it's a school or a hospital, I know they're often similarities between the details between one and the next, which is for efficiency, but essentially every different building is a prototype, isn't it? It's a brand new thing for a brand new site and a brand new, you know, set of requirements from that client or whatever.
Yeah, and you know, a bungalow or a 2-story house is relatively simple.
Yeah, for sure.
It's not simple, but it's more simple than an apartment block where you're trying to look at fire from one flat to the next, up and down, left and right. You're looking at the same with acoustics. You're squeezing all the different mechanical kit in above a ceiling and trying to get it out, duct out. So there is a lot more going on, and the details need to be considered a bit more.
And you're only going to do it once.
Hopefully.
So you got to get it right.
You got to get it right.
To get it right.
And you learn from your mistakes, and you might not get it right first time, but by the time it's built, hopefully you will get it right.
Yeah. For sure. I think there's a lot more scrutiny now as well, especially when it comes to things like fire. People are looking a lot more deeply into the documentation around the building and the interactions again between the different elements in there. So having the say-so from the manufacturer is quite important. Are you guys getting asked for this quite a lot?
Yeah, especially in relation to fire. It's a hot topic.
And see what you did there.
And then,
but you're getting asked questions that aren't necessarily covered on the standard literature, because insulation gets used all over the place. There's a little bit of it in every element of the structure of the building usually. So trying to cover every single eventuality is kind of impossible, which is why you got to talk to TST, talk to the project spec managers, and work it through. I guess. I think we get a lot of questions about stuff that's a little bit.
yeah, I know in relation to cavity barriers, because I had quite a lot of dealings with them recently. Since they've been launched, let's say, and some of those details you can never test every eventuality. It's nigh on impossible to test every kind of junction like you've touched on already. So a lot of that will require the likes of a fire engineer's assessment and judgment, because ultimately we're absolutely fine with what's covered in that data that's there in the testing, but beyond that, it ultimately will need a third person kind of to gratify and sense check almost.
Yeah, there's a perception sometimes that architects are only interested in design, making something look good, and we do want it to look good, but there's a lot of technical stuff that goes behind it. So we're often asked, can you not just do that, or it won't take you long to do that? Well, the reality is it does, because we do have to go and check it. We have to talk to manufacturers. We have to compare with all of the different consultants' drawings, the structural engineers' drawings, the frame, everything that's going on. And you also need to check against different products. So it can take time. And you're also trying to forecast 2 or 3 months down the line, or a year down the line. Will a decision we make now make something more difficult at a different stage of the build process?
Yeah. So that having that accurate information, even if it's not on a standard data sheet, you're going to need something in writing from us, or from us and a number of other manufacturers that all works together, that doesn't contradict each other.
Yeah, and if the information is there already, it speeds up the process of talking with other people.
Yeah.
If we need to go and talk to you and send the detail across, we will do. It might take a little bit of time, but we'll hopefully get to a solution that we can then roll on to the next solution, and hopefully make it work.
Yeah, absolutely. Talking about the standardization a bit in a way, because obviously we've already said that everything's a one-off, everything's a prototype, but isn't it the case that if you're designing, a school to go here, here, and here, can't the basic structure and shell of the thing be the same, even if it looks a little bit different from the outside? Is that too simplistic? It probably is, isn't it?
It's in theory, yes.
Yeah.
But there's always something. There's always, the engineering might be slightly different because of ground conditions that change what the frame is.
Yeah.
There might be different planning conditions or acoustic conditions or fire constraints on it that make you think of it in a different way. Yeah. It would be lovely to be able to roll out the same design and the same detail. We might actually make some money, but it doesn't happen like that, unfortunately. People often say, I did it like that in my last project, or I've done it like that before.
Yeah.
And that mindset doesn't work anymore, because things change, regulations change, product certification changes. We have moved to a system-led approach rather than a product approach. And you can't just rely on one element of it anymore. You need to rely on the whole system, what the BBA certificate says, how it has been tested.
I mean, speaking of changes, I think the last couple of years and the next few years, it's been absolutely whirlwind of changes certainly with building regs and stuff like that, right? I mean, I imagine you've had quite a lot of hard work keeping up to date with all the different things that are going on.
Yeah, fire change 2019. We then had update to BR443. I think that was the same year.
Yeah, that was in my time. TSD.
Part L changed.
Yep.
Obviously, we had the transitional arrangement, but then it changed fully. And now we're sort of gearing up towards future home standard later this year. So yeah, it's all changing, and yeah, you know, it's important that we know what's changed, why it's changed, and what the differences are.
Yeah, and the future home standard is a big one. You know, as is overheating, as is fire. But in terms of thermal and looking at the build-up of details, you know, it's all very well and good having a good U value through a wall, but if there's a weak point at a junction with something else, it's those areas that we need to start looking at now in a little bit more detail.
Absolutely.
Yeah, I think as the U values for plain elements like walls and roofs and floors reducing, so they're getting lower and lower U values, those junctions start to become more and more important because they're a bigger, you know, relatively a bigger area of heat loss, aren't they?
There, it's the weak point. It's not easy to build a wall, but to calculate a U value through that wall is relatively simple.
Yeah.
To actually calculate it through a junction where you have a lot of things going on is a little bit more complicated and just needs a little bit more consideration.
Well, up until, I don't know, I think it's about 5 or maybe a bit more, a few years ago, we weren't getting asked about psi values at all. So where the psi values around, you know, at the head of a window or the jambs or a sill of a window in particular, because, you know, it's a place in the building where your inside literally connects to the outside. So it's a real heat path. We weren't getting asked about that stuff hardly at all, and now it's almost a daily occurrence.
No, well, it used to be that you could use a typical value in the SAP calculation, and it was relatively easy. Not easy, but it was easier to pass a SAP with the typical values. But what they did in a recent Part L is they changed the typical, they increased it. And with the drive to net zero, you now can't rely on that typical value to pass a SAP calculation anymore. You need to actually start looking at the psi values and improving those areas to make your calculation work.
Yeah, we have a psi value calculator that will, yeah, if you go on there, search for different junctions, it'll give you options to change insulation, change your block types, and that's something we're constantly developing to add more variety, ultimately give you more choice.
Yeah, and the SAP software, SAP will change, and it will change as the future home standard comes in. So there's the home energy model that is coming in that is a lot more sophisticated in how it will work, and it will need that level of information on psi values.
And a lot more data points
And a lot more data
you're going to
points
have to go out and gather from your manufacturers.
Yeah, it's above my level of brain ability to comprehend it all. But
I'm not sure it's quite settled yet. I think there's still quite a lot of talking going on about it and quite a lot of consultation. So
there is, and the software is not out yet. Nobody knows exactly how it's going to work. Nobody knows exactly what the future home standard targets will be. We're still all guessing.
Yeah, I think there's a small group of people who are kind of at the forefront of all the discussions and the consultations, and maybe the rest of us are kind of just waiting to find out what drops out of all of it.
Yeah, and we have clients come to us and they are looking to develop stuff that is above building regulations, that is future home standard, and we have information that we can use, but it's not all there yet.
Yeah.
We can do our best with what limited information there is available.
So in terms of the accuracy of the information, you're going to be leaning on us as a manufacturer pretty hard to hopefully find it in the standard downloads from the website, but if not, speaking to somebody over the phone or emailing or you know, getting somebody in your office to sit down and talk to is a pretty kind of valuable service.
It is, and talking to the manufacturer, being able to use the psi calculator, the psi value calculator, will be useful, because if you have a complex building, there could be dozens, if not hundreds, of junctions in there, and if you have a typical psi value for a junction, great, you can roll it out. But if you don't and it needs calculating, it can stack up pretty quickly, the cost of doing that.
And they're pretty complex things to do. We're doing, quite a lot of them. And just building the model that expresses the thing properly in either 2D or 3D is really not an easy thing to do. Because especially if you're trying to translate a 2D CAD drawing into a 3D model to calculate heat loss, sometimes the person who's made the drawing is thinking of a horse, and we look at the drawing and we're thinking of a cow. Do you know what I mean? Yeah. And it's a big thing with 4 legs, but it's not exactly the same. And that accuracy, you've really got to drill it down into those calculations, and then they've got to match up with the U value calculations. And it's getting more and more kind of a niche sort of expert bit of knowledge to be able to do these kind of things and put it all together.
It is, and most architects now are modelling in 3D in some form or other. They might still be doing the details in 2D most of the time, because it's simpler and you can represent all the different products together. But we do need, on occasions, to represent it in 3D, because if there is a lot going on in a detail, it's actually quite hard for somebody to look at their little bit. If you're installing the boards, you're only focused on that bit. If you're doing the brick, you're only focused on that bit. So, but sometimes you need to actually put it into 3D, into a detail, so that people can actually understand the sequence of what goes together.
Because that accuracy is like so important. You get something just slightly wrong, and it messes up all your calculations, messes up your building essentially if you don't get it right first time.
It is, and the process involves trying to figure out the typical detail first, and then roll it on to the non-typical details. So you've got the principal set, and then you can figure out all the more complicated junctions. But you're never going to have every bit of a building always detailed. No, there's going to be a bit you don't foresee and think about, and it's at that stage when somebody's ready to build something and they want the drawing quickly, you need to be able to move quickly and get a drawing out.
Yeah, I mean, that's why our standard stuff, we rely pretty heavily on the standard stuff, like I say, the data sheets and the install guides and the design guides and all the, we've got loads of downloads on the website of EPDs and different things, but there's always a need. There's always one more thing. Like Columbo, it's just one more thing. So you need to know where you can find somebody with the answers to that stuff.
You do, and the website's great, but you need to get into the BBA certificates to actually look at the detail of it. How was it actually tested? What system was it tested with? And sometimes we need to get into the actual fire test report, whether it be from Warrington Fire or whoever. You're actually trying to figure out what the range of information was that was in the fire test, because you need to make sure that it's going to work.
I don't think we're at the point where Revit and AI is going to be able to work it all out for us just yet.
No, people think it might, but no, it still needs a bit of normal brain knowledge in there.
Yeah, it's the human interaction on a lot of things, just to reinterpret and
to understand it properly.
Yeah, they are very technical, aren't they? And the understanding, it can not ambiguous as such, but it can be interpreted certainly in different ways. So the third-party assessments, keyword, etc. They are really handy actually on the assessments, definitely.
Just going back to the U-value point there about accuracy of data, for us it's really sort of gold in, gold out. What I mean by that is you could go online and download yourself a U-value software. That software would use a lot of default values for materials. A lot of materials in there are taken from things like BSEN 12524, and you might be doing a calculation that's got cement board and plasterboard. A lot of softwares out there will use a default value for cementitious board, and they'll use a default value for standard plasterboard at 0.21. Now, you might be doing yourself an injustice there, and you might end up over-specifying on installation, which could ultimately cost the client more. because that data is not representative of the materials that you're using. So what we would always encourage people to do is to use declared lambda values from things like data sheets. You know, if you look at standard wallboard in a lot of typical U-value software, it comes in with a lambda at 0.21.
Yeah, still.
Now, no UK manufacturer of standard wallboard has a board out there that's 0.21. But a lot of these systems and softwares that are out there haven't been updated since Adam was a boy. So, you know, it's really important that you come and speak to us, because we can reduce the thickness of your wall and help you save where we can.
Yeah, absolutely.
And with accuracy, there's a huge focus for us and in the industry at the minute about competence and about demonstrating our competence and things like the Building Safety Act. We have to reassure our customers that we are producing accurate sort of calculations. The way we do that is so everyone in my team that issues calculations to customers are part of an industry competency scheme. So you've got that reassurance that this calculation is of merit. You know, we don't put anything on it that's ambiguous. We don't sort of fiddle with the values, which we know sometimes happens, but we are very sort of mindful of producing accurate calcs, so that ultimately the building performs as it's meant to.
Yeah, and it's about that audit trail, isn't it? It's about keeping the documentation that says, when I specified this product, it was suitable for what we wanted it to do. Now, that might change 5 years down the line, and things have changed in the last 5 years, but you still need that audit email document that says it was this at that time.
And for you, it's important, like you say, comparing apples with apples. If you've got a calculation from two different manufacturers, both achieving the same U value, one might be 20, 25 mil bigger than the other. And it's important for you to understand why. So we're being able to break down that calculation and go, right, they've used the generic value, they've used the declared value from the manufacturer, and just being able to put the pieces together.
Yeah, and in recent years, it has changed. So it used to be that we could put different products together, and it has become a lot more complicated. There's a lot more fire engineering, a lot more structural fire engineering analysis that goes on to piecing together different products. So to have one system that we can rely on, whether it be yours or whoever's, that you have a fire test certification plus all the thermal values plus a suite of details that we can roll out, it saves us time, and it gets you to a building that hopefully works.
Yeah, we're doing a lot of work with various other manufacturers as well, because you know it's not always possible to get a Knauf insulation system all the way through the wall if there's lots of different, you know, there's steel elements and board elements and you know, brackets and fixings and all sorts of stuff. So there's a lot of work going on at the moment to work with those complementary manufacturers so that everybody's got confidence that all the elements can be used together. There's very few options out there where you can just get everything for a wall off one shelf.
Yeah. And as the Building Safety Act has come in, and it's not necessarily that all the rules have changed, the interpretation of some of the rules has changed, and especially in terms of non-combustibility and of products. So to have manufacturers talking to each other, and the insulation working with a cavity closer, working with the different brackets, working with the different sheeting boards, with the SFS, the light gauge steel frame, that's what we need, and that's the technical data and the detailed information that we need to be able to be confident that the building will work.
Yeah, it's interesting. I mean, it's not only the interpretation as well, it's the level of scrutiny. The fine tooth comb has become a bit finer that people use to go through all of this stuff.
It has, and it's not just architects looking at it, it's building control have upped their game. Fire engineers, you wouldn't really touch any large building without a fire engineer now, where it used to happen.
Fire engineers are as well, what should we say, becoming ever more conservative about what they'll be able to sign off on. What something that at one time seemed to be just common sense, is now actually being drilled down to in some detail.
Yeah.
And if there's any questions raised at all, then they come washing back towards the manufacturers, we find.
Yeah, there used to be a lot of different rules of thumb that they would use, and they don't use them anymore.
No.
And even if they are using them, we are being asked to get evidence that it will actually work in this scenario. So it may be CFD analysis, for instance. It may be the structural fire engineering reports. And if the information is not there, we need somebody to get the information there. But if it is there from a manufacturer or Knauf, it obviously helps.
Yeah, I mean, generating that information is quite a long and costly process, especially if it's for if it's for an uncommon detail or something that you don't see every day.
Yeah.
For just that one-off detail for that one building.
Yeah.
You might be scratching around for that detail for a long time.
Yep.
And on the one hand, you're kind of thinking, wouldn't it be nice if everyone just went for standard details? But on the other hand, this is a unique building, and that's not always possible. So there's got to be some middle ground there, with a compromise that works it all out.
It does, and when people think we want it to look good, but I'm asking questions if I can turn a bracket upside down, they're complete ends of a spectrum.
Yeah, they definitely are.
For things like raised screen facade construction, where you've got brackets and rails that penetrate your insulation layer. Brackets like this, for example, you have significant heat loss through these brackets, which are typically aluminium. Some of them you can get stainless steel. Now, it is very difficult to account for this in a simplified U-value calculation. You can use a default, but if you use a default correction in a simplified U-value calculation, it will add 0.3 to that U-value. So it pretty much destroys it. You won't be able to get an achievable U-value by using the default correction.
You're looking at a much thicker build-up versus what Brad's going to
you'd need a significant amount of insulation. And to be honest, you get what we call sort of diminishing returns. If you increase this bracket length to, say, be 0.5 metre, you've still got the same cross-sectional area of that thermal bridge, if you will, penetrating that insulation layer. So using a default isn't the way to do it. There's then a couple of other options. You can do what we call a point loss and add a correction for that. So you can do, it's called a quasi-adiabatic area. So you take a section of your facade that is quasi-adiabatic, so essentially an area between 2 points, and you can model the build-up with a bracket, and then you model the build-up without the bracket, and then the difference in the calculations is what you call your point loss, and then you multiply that point loss by the area. Modelling a representative section of your construction with the actual brackets and sort of bracketry that you're going to use, so your brackets, your rails, it's the most accurate way to do it. It takes into account the geometry of the bracket. We model these in a software called Trisco, and we will put in the bracket dimensions, the base length, the thicknesses, and what you'll notice with brackets is they're not made equal. And again, it goes back to the point on accuracy. Is you might have had a 3D calculation done for a particular build-up 6 months ago using this bracket, but then your current design may be using this bracket that's thermally broken, and using the calculation that you did for this bracket, you can't just transfer that over. Everything has to be modelled bespoke to give you an accurate calculation that reflects the design that you're building. So we do that in-house, and again, it's just a case of speaking to us. You'll liaise with Callum and his team. All we do is we understand what it is you want to build, what materials you want to incorporate into that design, what brackets you want to use, the frequency of the brackets, which depend on things like your wind loading, and then we will model a representative section of that design and do you an accurate calculation, which you can have confidence in.
It sounds very complicated.
It is, in a way.
the adiabatic.
But the beauty of it is it's complicated for us and not complicated for you.
Yeah, and so the beauty of it is that you do that for us and we don't have to. So, I don't need to understand what software you use. I don't need to understand all of that. I need to understand roughly the principle of it.
Yeah.
But at the end, I want a nice clean sheet of paper that gives me a psi value or a good breakdown of what I need to do to achieve what I need to achieve.
I think the breakdown's important. So what we've been working on quite a lot recently is trying to communicate that level of complexity in a very simple way. So having the 3D calculation that's got pages that show what are the dimensions of the SFS that we've used, what are the specific brackets that we've used and the spacings between them and all that kind of stuff. What we're trying to give you is something that's easily understandable, that you don't have to spend a lot of time over, that's not, a spreadsheet with a million different numbers on it that nobody knows where they came from and they're in 14 decimal places. We want something that graphically represents this is what we've put into this calculation so that you can check it, satisfy yourself that it's correct, but also then hand it over to a main contractor who will then hand it over to a subcontractor. So everybody's absolutely crystal about what's going on. If anyone wants to change it, that's fine. Come back to us. We'll tweak it, make the changes, but again, then represent it in a way that is digestible to all the people I've mentioned and building control and everybody else involved in the project. You know what I mean?
Yeah.
So it's trying to boil that, 14 decimal places down into something that everybody on the site can understand.
And the summary is important because there'll be a lot of information there.
Yeah.
And I don't need to go through all the detail. I need to know roughly what's happening. But it may be that a structural engineer or building control are going to look at that in a lot more detail for wind calculations or make sure it's going to stand up essentially.
Yeah, absolutely. It's the communication of it and the clarity of it that we've been working on really hard lately.
And it's all illustrated in the report that we produce for you. So you get the report, we've used that thermal pad, we've used that bracket, and we've put whatever insulation in to meet your sort of target U value. If you then want to change the bracket design or the frequency of the brackets, we will revise that calculation for you.
Yeah, so it's tailor-made to suit the bespoke construction project. As you say, each one's almost a prototype. So, and certainly on the drawings that put with my specification hat on, the amount of times we'll see the cladding drawings that'll have like T-rails, for example, bridging the insulation. And when we actually look at the final output in the U value, you can categorically tell that they've not accounted for that. So things like that have a massive impact on that overall U value. So certainly when we do them in-house, if we have to account for that kind of thing, it's all made clear in the form, and we ensure that it is as accurate as it can be.
Yeah. And I think with the Building Safety Act, there's been a huge clampdown on contractors and people on site changing stuff because they can. So we would often get, we've changed that bracket to this bracket, and we've not made that decision, but it has come to us and it's almost installed already. That shouldn't be happening anymore with the Building Safety Act over 18 metres.
I don't think there was any sort of malice or even...
No.
Yeah, it's not even... It's just changing one little thing has such a knock-on effect to potentially so many other things.
It does.
And people doing it in good faith and not realising that was the knock-on effect, because they're looking at their part of the building or what they've got to do, what the job they've got to deliver, and they can't be sort of held accountable for what knock-on effects that's going to have. But somebody somewhere in the project needs to be the final, the final buck needs to stop with someone, right?
It does, and it may be that the decision to change it might have been because they couldn't get that one, for instance, or the availability. And they've made a good judgment that the product they've chosen still works functionally, but it might not work with your 3D U value calculation, or it might have an adverse effect on something else.
Yeah, and that record needs to be, that golden thread needs to be up to date. So from our point of view, trying to get the accuracy right, getting the right amount of information in from the site, in from whoever's making the decision on this particular day, and then reflecting that in revisions to all of our calculations in a way that's easily shareable with everybody, so everyone can, making it visible what's changed, what's happened, what's in the calculation, what's not in the calculation. It's something we're really working hard on at the moment.
And change control is becoming much more important. And I think there's been a huge upskilling of everybody in the industry, architects, contractors, manufacturers, everybody's tightened their game up a little bit because they needed to. Changes needed to be made, and the people were making changes without malice, as you say, but without actually understanding how it impacts on other things.
Yeah, it's difficult, isn't it? It's difficult.
One of the things we're doing to make life even easier for architects and specifiers is we've developed an online UVI calculator in recent years. It's free, it's easy to access on our website, and that contains build-ups and solutions for all elements, so walls, roofs and floors, and you can go on there, it's dead easy, plug and play. If you will, go and select the variables that you want. You can change your block types, or you can change your substrates. For example, if it's rain screen and it spits out a value that then you can download, and it's free, it's instant, it saves time for you, and it lets you sort of do unlimited iterations if you want to sit there all day and adjust different variables and see what you can do to tweak your design. It allows you to do that. One of the things we're doing to expand on that tool is to incorporate 3D UVI calculations. So it will have the functionality that lets you create your own bracket layout using whatever combination of single and double brackets that you're using. It will give you options for different bracket types. When it launches, it will have 3 bracket types on there, a mix of aluminium and stainless steel, and then it will obviously allow you to adjust your insulation thicknesses as well to meet whatever sort of target U value you're looking for. So you can change the insulation in your SFS, the thickness of your SFS and your sensors. You can also change the thickness of your rain screen insulation as your sheathing insulation to sort of really sort of tweak your design to do whatever it is to meet your needs and get that target U value. It'll be a real asset to a lot of architects, I think, when it launches, and it'll give you so much flexibility to tweak your design, and it's something that we're going to develop moving forward to include more bracket options and more customization, so you can really go to town with it.
Yeah. And I think the more information we have, the better, because we might be running with 3 different strategies at the same time, because you don't know, you've not talked to the contractor or the subcontractor. The SFS thickness may change because of wind loads, and you don't have that information yet. So you're trying to keep it as flexible as possible for as long as possible, but at some stage you need to firm down on exactly how you're going to build it.
Yeah, we fully expect to do revision after revision on, the more complex the job, the more revisions that we see, and that's where what we're expecting to happen is people start off online, and then they'll find that they need to speak to somebody. They've got so far, and then it's we're not taking away, we're not replacing the human interaction with the online tool. The online tool was there to complement what we do, in TST or in my team, where somebody will come and talk to you face to face or on Teams. So I think it's an additional string to the bow, which will be really useful for people.
Yeah, and I think the rush to site that used to happen, we need to be on site by March.
Yeah.
It's not going to happen as much anymore, particularly for bigger, more complex buildings. So it allows everybody to actually focus on their bit a little bit more and get the design right, so that you're not changing something when the steel frame is up and you're firefighting all of a sudden. Hopefully not. We use a range of different sources. So we use NBS, Chorus and Source. We do love a good manufacturer's website where we can get details and BBA certificates pretty easily off them. And then all architects are required to do CPD, continuous professional development, every year. So for rebates, 36 hours of continual improvement, continual learning for all of our staff. So we will have manufacturers come in, talk to us about their products, talk to us about new regulations. I believe you guys have been into us before, and will be into us again, no doubt.
Hope so.
So what CPDs will you be offering with all these new regulations and new value services?
Yeah, so our expanse around CPD, if you will, it's certainly ever changing. I think currently we've got a list of around about 9 or so. I think currently, as we're speaking, we have 2 that are REBA certified, and the rest, certainly some of them are going through the process of being formally REBA certified as well. But we've got topics such as embodied carbon and how prevalent that's going to be in buildings as we move towards future homes and things of that ilk. We've got rain screen facades, also high-performing masonry elevations. Again, they're quite prevalent. We're seeing in different areas, whether it's cladding, whether it's masonry. Then we've got the ones that touch on Part L, for example, and the recent changes there. And we've got one that's, whilst it's on my head, in terms of the Euroclass reaction to fire.
Yeah. Well, what we're trying to do essentially is cover all the topics that are relevant to insulation. So there's thermal, acoustics, fire, sustainability.
Yeah.
So covering those 4 at a topic level, but then also drilling down into individual applications, whether that's walls or roofs or whatever, but also ticking off all those thermal, acoustic, fire, sustainability boxes, but for a specific application. So whichever way you want to look at it, you can just go online onto the website, fill the form out, or speak to somebody in Callum's office, or speak to one of the PSMs, or TST will direct you in the right place. But whichever way you want to access it, whether it's in person or an online live or an online on demand, we're trying to cover all the boxes for all the different ways that people work and what their preferences are.
Yeah, and we have people who work at home some of the time, other people who like coming into the office, so that offer is useful. You don't get a sandwich if you're working at home. But
that's true, yeah. Providing people with lunches when you're doing it online is always way more difficult for us. I mean, we could go on Deliveroo and get you Domino's or something, but it's not as easy.
And I think the hierarchy of CPD now, there was for a long time a drive of just looking at thermal, but fire is becoming ever more important, acoustics becoming ever more important. So it's a broad range of CPDs that need to be offered and are offered, obviously.
Yeah, certainly more in the pipeline as well, as far as I'm aware. So certainly that development's going to be just diversifying.
Our 3D UVI calculator is now live. Click the link attached to this video to access.